Alright, in this video we're going to check over the homework that we had, the practice problems for adding fractions. So the first thing that I'm going to do is I'm going to use the first strategy that we went over in class, which is the second strategy, which is the equivalent fractions method, so that we can get a common denominator. So I'm going to write my first fraction 1/3 and my second fraction 2/5, and I'm going to put a little line right there so you can see where my multiples are going to start, my equivalent fractions. So my equivalent fractions for 1/3, we're going to start with 1/3. Another one is going to be 2/6, and then 3/9, and then 4/12, and 5/15, and I could keep going on. But I'm going to stop right there, and I'm going to do the second fraction to see if I got one that has the same one. So I'm going to have 2/5 for the first one, and then if I multiply times 2, I'm going to get 4. If I multiply 5 times 2, I'm going to get 10. So 4/10 would be the next fraction. Then I have 6. If I multiply the original 2, times 3, that gives me 6, and then 5 times 3, that would give me the 15. Notice that now I have an equivalent fraction for both fractions that has a denominator of 15. So I can stop because I'm going to use these two fractions, 5/15, and I'm going to add it to 6/15. Since 5/15 is equal to 1/3 and 6/15 is equal to 2/5, then whatever the sum of these two fractions is going to be the same answer as if I add 1/3 plus 2/5. So I'm going to go ahead and add the two numerators. 5 plus 6 is 11, and then I'm going to leave the denominator the same. So 15 plus 15 is not going to be 30, it's going to be 15. It stays the same. Notice that the denominator does not get added. That's one of the common mistakes that people make when they add fractions. They also add the denominator, and that's incorrect. So my final answer is 11/15. Alright, I'm going to go a little faster because there's 10 problems that we have to go through, and I don't want this video to be too long. So here is the next problem. We have 7/10 and we have 2/4. So I'm going to again look for my equivalent fractions. The first one is going to be 7/10. The next one is going to be 14/20, and then 21/30, and 28/40, and so on. And then the next one for the 2/4 is going to be 2/4, and then 4/8, 6/12, 8/16, 10/20, and so on. But I can stop right here because I have an equivalent fraction for 7/10 and for 2/4, and they both have the same common denominator, which in this case is 20, as you can see that I highlighted it for you. So now I'm going to take my 14/20 and I'm going to add my 10/20, and that's going to give me 14 plus 10, which is 24. And the denominator stays the same. Okay, so my final answer is 24/20. Now, we talked about this in class. This is an improper fraction, so we would normally change it to a mixed number. But for this homework problem, I'm going to allow you to leave your answer as an improper fraction, because that's not the focus of this worksheet. The focus here is to be able to find common denominators by one of the two strategies that we talked about in class, and then add the two fractions together so we can get a final result. So now the next fraction is 1/4 and 1/3. If I do my equivalent fractions of 1/4, I end up with 1/4, 2/8, 3/12, 4/16, 5/20, and I'm going to stop right there. I'm going to go to the 1/3. So 1/3, 2/6, 3/9, 4/12, and I can stop there because now I found my common denominator, which is 12. So now I'm going to use those two fractions just like I did before, 3/12, and I'm going to add my 4/12 to it, and 3 plus 4 gives me 7, and you can see that I kept my denominator the same. So 7/12 is my final answer. The last problem for this screen is going to be 1/2 plus 2/4. If I do my equivalent fractions for 1/2, it's going to give me 1/2, 2/4, 3/6, 4/8, 5/10, and so on. My equivalent fractions of 2/4 is going to start us with 2/4, and that's all that I need because I already see a denominator of 4 in the top list of fractions, of equivalent fractions. So what I'm going to do is I'm going to use those two fractions, which is 2/4 plus 2/4, and in this case it came out to be the same fraction, which is fine. All I'm going to do is follow the same rules. I'm going to keep the denominator the same, and I'm going to add 2 plus 2, which is 4. Now notice that I have 4 over 4. So that is going to be equal to 1 whole. So I will take either one of these two fractions as your answer, 4/4 or 1 whole. All right, for the next set of problems, 5 through 8, I'm going to use the other strategy, which is finding the least common multiple for the two denominators for the fractions that we have. So the first thing that I'm going to do is I'm going to do my list of multiples for my two denominators, which is 10 and 5. So I'm going to skip counting by 10. So there's 10, 20, 30, 40, 50, and so on. The second denominator was 5, so 5, 10, 15, 20, 25, and so on. You can see that I have a least common multiple of 10. That's the smallest number that's in common. We also have this 20 that's also in common. And you can probably guess that we'll have a 30 as well. That would be in common. But the one we're looking for here is the smallest one, the least common multiple. So in this case, the least common multiple is my 10. I'm going to use that least common multiple to rewrite my two original fractions. So my original fractions were 3/10 and 4/5. Notice that what I'm going to do here is I'm going to leave some space so that I can write my scale factor in just a minute. And I'm going to rewrite my denominator as the new denominator that I'm going to use, which is 10. That's my LCM, my least common multiple. So the first fraction is kind of simple because it's already at 10. So all I have to do is multiply the 10 times 1 to keep it at 10. And if I do that to the denominator, I have to do the same thing. I have to multiply by the same scale factor, which is 1 in this case, to the numerator. So 3 times 1 is going to give me my new numerator, which is 3. So my new fraction of 3/10, well, it's not really new, it's the same thing, it's 3/10. But 4/5 is going to be a little different because the 5 needs to be turned into a 10. And I can use a scale factor of 2. 5 times 2 gives me 10. So if I use that scale factor in my denominator, then I'm going to do the same thing in my numerator. So 4 times 2 is going to give me my 8. Now you can see that I have my two fractions with the same denominator. In this case, it's the 10. And all I have to do is keep the denominator the same and add the two numerators. So I'm going to say, if I put the 3 and the 8 together, that's going to give me 11. So I have 11 and the denominator stays the same. So 11/10 is my answer for number 5. I'm going to use the same strategy for 6, 7, and 8 so you can see it and you can practice it. If you did it a different way, that's fine, as long as your answer is the same as mine. But I do want you to hear it so that you can keep practicing at least on this other strategy of the LCM, okay, of why we use the LCM. So the very first thing that I'm going to talk to you about is the 3 and the 2. Let's do that list of multiples for the 3 and the 2. So if I skip count by 3s, I have 3, 6, 9, 12, 15, and so on. If I skip count by 2s, I'll have 2, 4, 6, 8, 10, and 12, and so on. Now you can probably see that I have a 12 and a 12 right there, so I can stop, right? But be careful because this will not be the least common multiple. We have a 6 that's smaller than 12. So the least common multiple would be 6 in this one. So now I'm going to rewrite my original fractions and I'm going to change them to be fractions with the new denominator, which is going to be my LCM, the least common multiple. So in order for me to make the 3 a 6, I have to multiply by 2. So that's my scale factor for that fraction. So then I have to multiply the numerator also by 2, and that gives me 2. The scale factor that I need to use on the bottom fraction, the 1/2, in order for me to change the 2 to a 6, is to multiply it times 3. So that's my new scale factor. So 1 times 3 for my numerator is going to give me a 3 for my new numerator. So now I've got to do is add the two fractions together. If I add the two numerators, 2 plus 3 is 5, and the 6 stays the same. So my final answer is 5, 6 for number 6. Finally, 7 and 8 are going to go kind of fast. So here we go, 4 and 5. Do my list of multiples. 4 is going to be 4, 8, 12, 16, and 20. For 5 is going to be 5, 10, 15, 20, and so on. 20 is my least common multiple. So I'm going to rewrite my original fractions using my new scale factors, that is my new denominators. And the scale factors that I'm going to use for that is going to be 5 for the first one. So 1 times 5 is going to give me 5. And it's going to be 4 for the bottom portion of the bottom fraction. So 2 times 4 is going to give me 8. If I add these two fractions together, 5 plus 8 gives me 13. and the denominator stays the same, so I end up with 13/20. The next fractions that I have is 3/4 and 1/2, so I'm going to use the 4 and the 2 to do my list of multiples. So here I go, 4, 8, 12, 16, 20, and for 2, so it's 2, 4, 6, 8, and so on. You can see that I have a 4 in common, that's the smallest number that I have, so that's my LCM, my least common multiple. I'm going to rewrite my fractions, 3/4 and 1/2, using my LCM as my new denominator, and I'm going to use a scale factor of 1 on the first fraction. 4 times 1 is 4, so 3 times 1 is 3. The scale factor for the second fraction of 1/2 is going to be a 2. So 2 times 2 is 4. So 1 times 2 is going to give me 2. Put these two fractions together, and 3 plus 2 is 5. 4 is the same, keeps the same denominator as before. So there are my answers for 5 through 8 using the LCM strategy. Now for the last two problems, 9 and 10, what I'm going to do is I'm going to use the LCM for number 9, and I'm going to use the equivalent fractions for number 10. So you can see both strategies side by side. So again, I'm going to do 5, 10, and so on, and then 10, and I can keep counting 20, 30, 40, but I don't need to because I already found the least common multiple, which is 10. So I'm going to rewrite my fractions using my LCM as my new denominator. And in order for me to change that 5 to a 10, I have to multiply it times 2. So if I do the same scale factor to the top, to the numerator, 1 times 2 is 2. On the denominator on the second fraction, all I got to do is multiply by 1, so it stays the same pretty much. And if I put the 2 and the 4 together, the two numerators, I end up with 6. The denominator stays the same, so my answer is 6/10. And then number 10 is going to be 1/4 and 8/10. Those are my two fractions. And on this one, I told you I was going to use the equivalent fractions strategy. So I'm going to do equivalent fractions of 1/4. So 1/4, 2 8s, 3 12s, 4 16s, 5 20ths, and for the 8/10, it's going to be 8/10, 16 20ths, and you can see that I have a common denominator right there, where 20 is the same number. So all I got to do is add 5 20ths plus 16 20ths, and by the way, I like those numbers right there, 5/16. That's my birthday, May 16th. May is the 5th month, and 16th is the day that I was born. Cool, huh? Anyways, so 5/16, 5 plus 16 is going to give me, oops, let me erase that right there. There you go. 20 is going to stay the same, and 5 plus 16 is 21. Sorry, I got a little distracted because I got excited about my number showing up. So my answer is 21/20. And that's it. Hopefully you got all these questions right. If you have any questions about using these strategies, please see me during class or during AM time or any time at all. Thanks for watching.